All right, so we're going to do some of these example problems on acceleration. Let's kind of remind ourselves that acceleration is final velocity minus initial velocity over time. All right, so when we look at this, we are going to have a difference in time and then our difference in velocity over time. So let's practice the problems that we have here on the screen. We have number 1, a roller coaster car rapidly picks up speed as it rolls down a slope. As it starts on the slope, its speed is 4 meters per second, but 3 seconds later at the bottom of the slope, its speed is 22 meters per second. What is its average acceleration? Okay, so if we know that we're going to use this formula, we need a final velocity, an initial velocity, and time. So as it starts down the slope, its speed is 4 meters per second. So that's the initial velocity. At the bottom of the slope, its speed is 22 meters per second. So for what we're considering, that's going to be the final velocity. And it took 3 seconds to get there. So then we're just going to plug in the numbers. 22 meters per second minus 4 meters per second over 3 seconds. So let's put our units on our time. So 22 minus 4 is 18 meters per second over 3 seconds. So 18 divided by 3 is 6 meters per second. So this is our answer, but let's look at that unit and make sure we understand how the unit becomes meters per second. So we're just going to look right at the units right here. So if I have meters per second divided by seconds over 1, because there's always an invisible 1 around our numbers. What we're really doing, and I started to do that with the writing, but what we're really doing when we divide by a fraction, we're going to multiply by the reciprocal. So we would really have meters per second times 1 over second. And so when we multiply straight across, we get meters over second times second, which would be second squared. Okay, so that is why our unit is meters per second. All right, let's look at number 2 on the worksheet problem. A cyclist accelerates from 0 meters per second to 8 meters per second in 3 seconds. What is his acceleration? So that's the first part of the question. Is this acceleration higher than that of a car which accelerates from 0 to 30 meters per second in 8 seconds? So in this one, we're going to compare 2 things. So I'm going to separate my problem and say bicyclist and car. Okay, so our bicyclist is going to have a final velocity, an initial velocity, and a time. Okay, our car is going to have a final velocity, an initial velocity, and a time. So let's look at the bicyclist accelerates from 0 meters per second. So 0 meters per second is the initial. They're stopped standing there. To 8 meters per second in 3 seconds. So let's calculate that acceleration. So 8 minus 0 is 8. We probably could leave that part out, but for clarity, we're going to make sure and keep it in there. So this would be 2 and 2/3, which is 2.67 meters per second. Okay, and then our car accelerates from 0. So we're going to start from a standstill to 30 meters per second in 8 seconds. So it takes this car longer to get to that 30 meters per second, but that's a greater velocity. So let's see what the acceleration is to compare those two. Acceleration equals 30 meters per second minus 0 meters per second. So again, we could probably leave out this part of the calculation, but we want to have plenty of clarity. And so we're going to say 30 minus 0 is 30. And so we would get 3 and 6/8, which is 3/4, 0.75 meters per second squared. So when we look at which one of these has a higher acceleration, the car clearly has a higher acceleration because we have more meters per second. So it's asking in the question, is this acceleration higher than that of a car? So our answer, we would say no. The bicyclist has a slower acceleration. Okay, so hopefully these example problems helped you to kind of go through the formula that we kind of started looking at today. All right, have a great day.